Hi, my name is Jorge Chavez. I'm Senior Manager of Broadcast Products for Mexico and Latin American Experience. On this opportunity, I'm going to talk about the technical features of the iVoc standard. And the main topics of this session will be how HD radio works, broadcaster equipment requirements, the HD radio services, the techniques to improve system robustness, the single frequency networks. Experienced HD radio technology enables the transmission of digital radio signals within the same band as analog, sharing the same channel. This method is called in-band on-channel digital radio. It allows for a hybrid transmission mode where existing analog signals are maintained, while low-level digital signals are added adjacent to or underneath the analog signal. The HD radio signal can carry the same content as an analog signal, including audio, song title, and artist metadata. It can also offer additional audio channels and other digital content such as images or unrelated data. Analog radio receivers are compatible with hybrid analog FM and HD radio transmissions. And HD radio receivers can switch between analog and digital signals as needed. Extensive evaluation by the National Radio System Committee (NRSC) led to a recommendation for the FCC to adopt HD radio iVoc technology. HD radio system consists in four main components: the modem, the codec, forward error correction or FAC coding, interleaving, and blending. These elements are integrated to meet the HD radio requirements. Xperi selected quadrature phase shift keying for modulation because its robust performance and sufficient throughput for near CD quality digital audio. With a bandwidth efficiency of 2 bits per second per hertz, QPSK provides the necessary bitrate for high-quality audio transmission. For transmitting the digital signal, Xperi opted for orthogonal frequency division multiplexing, OFDM, which use multiple QPSK modulated carriers that do not interfere with each other. OFDM is highly resistant to multipath interference. HD radio technology was first introduced with a digital power of 1% of the authorized analog power. This reliability, low digital power level was selected to eliminate the possibility of creating interference. In this slide, we illustrate an example. For analog 10 kilowatts, we see that 1% of the analog power is 100 watts total integrated power. It means 50 watts per sideband. At 10% of the analog power, the digital is 1000 watts total integrated power. It means 500 watts per sideband. Fully spaced station may operate with 10% digital power on both the upper and lower sidebands. The MP1 mode HD radio waveform is comprised of 400 QPS key carriers, extended hybrid service modes, MP2, MP3, and MP11, and additional subcarriers closer to analog carrier. 2 out of every 5 bits are used for error correction, resulting in throughput for the extended hybrid mode of 148 kilobits per second. The placement and power level of HD radio subcarriers were carefully selected to maximize digital performance while staying well within the FCC emission limits. These limits reflect performance obtained by state-of-the-art transmitter designs. The HD radio iVoc solution is designed to meet ITU requirements for code channel and adjacent channel power levels. The hybrid service power is adjustable without causing any co-channel interference to the protected primary analog service. The digital transmission will operate in markets with 400 kHz channel spacing with no interference and no power adjustments. A logical channel is a signal path that transmits program content over layer 1 with a specific rate of service, as determined by the service mode. There are 10 logical channels, but not all are used in the service modes. The variety of logical channels reflects the inherent flexibility of the system. For a given service mode, each logical channel is assigned to a group of OFDM subcarriers, or frequency partitions. This spectral mapping contributes to the performance and robustness of the logical channel. There are four main logical channels. There are designated P1, P2, P3, and PEDS. The NRSC evaluation determined that IVOC MP1 mode minus 20 dBc provides uniform digital coverage to the 45 to 50 dBu signal level. Increasing the digital power to minus 10 dBc digital power extends digital coverage to 35 dBu level. This evaluation confirmed quality, coverage, and compatibility. The FCC has approved minus 14 dBc operation for all stations in the US. The FCC is considering a request to allow fully spaced stations to move to minus 10 dBc operation. The AM-MA1 hybrid mode offers higher reliability of service, a few dropouts for grounded conductive structures, in the daytime, a coverage beyond the 2 millivolts per meter, and in the nighttime, the typical usable coverage is between the 5 to 10 millivolts per meter. To broadcast the HD1 signal, a radio station must possess a transmitter that linearizes for Class AB amplification. Additionally, it requires an HD radio gene to produce layer 1 OFDM modulation. Also, it needs an exporter to create the HD1 HDC encoded audio programming for the layer and modulator. The HD importer functions as multiplexer for all services beyond HD1, such as multicast channels and artist experience and data services. The HD radio FM hybrid signal transmission is comprised of both a digital and analog signal component transmitted with the existing FM allocation. The FM hybrid signal transmission modes use the analog FM signal to provide a backup for the main HD1 channel. To produce these hybrid signals requires that the analog and digital be combined at low level in the exciter stage, at high level in the antenna system, or transmitted separately on purpose-built antenna systems. The preferred approach is the low-level common amplification. In this implementation, the low-level RF output of an analog FM exciter is combined with the output of an HD radio digital exciter. When HD radio was first introduced, initial station conversions were accomplished using the second methodology, high-level separate amplifications. This one uses one of the three methods to combine the analog and digital signals. A separate antenna implementation is a method where an HD radio signal is transmitted from an auxiliary. It means independent antenna from the analog. The separate antenna methodology reduces implementation costs and increases operation efficiency. It allows stations that already had an auxiliary antenna to quickly get their digital signal on air. Our transmission partners have brought their experience to optimize station integration. Across the US, Canada, and Mexico, there are over 250 combiner systems operating. They range from a slew of simple 2 and 3 station junction combiners to systems like the 19 station Empire Auxiliary FM combiner. And they support multiple HD and analog systems as shown in this example in New York City. HD radio transmissions include the following services: Station Information Service, Main Program Service, Supplemental Program Service, Advanced Application Services. Station Information Service provides station identification and control information. This service is transmitted in a series of protocol data units on the primary iBook data service logical channel. The service is information about real-time transmitted services, event schedules or calendars, and station-related system transmission information similar to existing RBDS services. In hybrid mode, the main program service is the digital equivalent of the analog station signal. It provides not only the audio portion, but also the song title, artist, and album metadata. Supplementary program services are audio channels that can be added to the main program service. The exact bandwidth of the MPS and SPS channels will be determined by the service mode, MP1, MP2, MP3, or MP11, and the number of multicast channels operating in that mode. Multicast channels and their respective bandwidth assignments are set in the imported equipment. The interface provides presets with the bandwidth combinations of the most common multiprogramming channels. The presets in the most modern equipment take into account the bandwidth necessary to transmit logos, images of album covers, text, and advanced services. Advanced Application Service allows a virtually unlimited number of custom and specialized HD radio applications. Advanced applications can be added at any time in the future. An example of this include HD traffic services and radio data casting functions. The metadata enhances listener discovery and engagement, and generating revenue for stations. Adding a station logo helps broadcasters to build brand equity, familiarity, and recall. When listeners see the logo in their car, they can recognize their favorite station. Radio stations can create a more immersive experience by synchronizing metadata with audio programming. Synchronizing advertising images and text with audio is a powerful monetization tool. Given the FM channel bandwidth limitations, HD radio employs the HDC codec to compress the digital bit stream to a maximum of 96 kilobits per second, ensuring audio quality comparable to CDs. The codec's error concealment techniques help maintain signal quality even when errors occur. The HD radio technology employs a patented first adjacent canceller to mitigate the effects of first adjacent channel analog interference to the digital. The FAC, which is simultaneously active in the upper and lower digital sidebands, essentially tracks the instantaneous frequency of a first adjacent channel analog interferer and nulls its effect on the digital information. The FAC and interleaving enhance the reliability of transmitted information by reducing lost data and spreading errors over time and frequency. This combination and superior modem performance allow the HD radio system to deliver high-quality audio beyond the protected signal contour in both fixed and mobile environments. Interleaving is a type of time diversity that scrambles and interleaves the audio bits at the exciter and resambles them in the receiver's decoder. This causes the data impairment to spread out over a longer time for easy error concealment. The HD radio system uses time diversity between two independent transmissions of the same audio source to ensure robust reception during typical mobile outage. This time, diverse channel is available in both the hybrid and all digital modes. If the primary digital signal is corrupted, the receiver blends to the backup audio, which remains ineffective by the outage. Due to the complexity of encoding and decoding through DSP, real-time digital transmission isn't feasible. This delay leads to an optimized system approach to enhance robustness. This optimization results in a 4.5-second intentional diversity delay to mitigate signal interruptions caused by obstructions like tunnels, and to ensure a smooth transition to the analog or backup digital channel if the primary digital signal is lost. The time alignment between analog and digital signals could be made in the following equipment: in the exporter, in the audio processor, or in transmitter or specialized equipment. A single frequency network is comprised of main transmitter and one or more complementary transmitter of lower power, called boosters. SFN boosters have a maximum ERP that is 20% of primary station's class. The service contour of an FM booster facility must remain within the predicted service contour of the main station. This is an example as a typical single-frequency network installation in a mountains in the western of the US. As we can see that the on-channel boosters are used to fill in shadow and gaps in the main station's coverage, whereas boosters fill in shadow areas by terrain. SFN are capable of extending coverage along a specific route. Highways that traverse unpopulated desert roads can be provided with a station coverage for their entire length. This slide is a high-level view of a typical HD radio booster SFN implementation. Broadcast Electronics, Gaitzer, and Nautel are manufacturers who produce and demonstrate single-frequency network gap fillers for HD radio. Thank you so much for watching this video of technical features of iVox standard.